Good morning, afternoon, and evening, everyone. Today we will be teaching a lot about physics too. We'll be teaching you on how to draw an FBD, on how to use certain formulas to solve certain problems, and yeah, first we would be teaching you on how to draw an FBD.
Hi, I'm Kobe Dominic D. Cruz and I'm going to discuss and show you how to draw its FBD of the two forces which are tension force and electrical force. But first of all, I'm going to start with the tension force. So basic introduction to it. So all physical objects that are in contact can exert forces on each other. So we have these different kinds of forces, but we give these contact forces different names based on the types of objects in contact. So if one of the objects exerting the force happens to be a rope, a string, a chain, or a cable, we call the force tension. So if you pull an object with a rope, the rope will stretch slightly. So I'm going to draw an FBD to be able for you to visualize it. So imagine that there's a roof. Then a rope is attached to it. Then a box is attached also on the rope. So in case here, the rope is pulling the box to maintain its position so the box will not fall. So this stretch in the rope will cause the rope to be under tension, which allows the rope to transfer a force from one side of the rope to the other. So that other is the box. So roughly similar to how a stretched spring will pull on objects connected to it. So the arrow or the direction of the force is upward, then gonna be T for tension. So that is the look of an FBD of a tensional force. So in other or some cases, I see some physics on some physics books. It's written like FT for tensional force. So why it is an upward direction? Because the rope itself is pulling the box upward for it to maintain its position. So that's it. Moving on to the next force, which is electrical force. So one of the fundamental forces of the universe is the electrical force. So this is the force that exists between all charged particles. The electric force is responsible for such diverse phenomena as making your hair stand up on a cold dry day, for some cases, creating chemical bonds, and allowing you to see when you turn on a lamp on a dark night. So basically, the bulbs. So the bulbs on our home are created or is caused by the electrical force. That is why they are turning on at some point. So there are two types of charge, positive and negative. So I'm going to try to visualize. So there are two charge particles, positive and negative. So when we're talking about positive and negative, so unlike charges exert attractive forces on each other. So positive and negative attracts. When positive and negative charges combine, it is it attracts the electric force. So bulbs and all of the electrical forces, the appliances that we use every day, it is created by the positive and negative ions, charged particles. So, while like charges exert repelling forces on each other. So if the particles are both positive or negative, it will repel to each other. So that is the science behind it. So to draw the FBD, it will look like this. Positive, let's say a positive and negative charge. Positive, negative, then we have here the force is inward direction force. So it looks like this. You see, that is the positive and negative charges combined with each other. It works. So our appliances works like this. So when we're talking about both positive or negative, it will look like this. Arrow outside. So it's like they are not facing to each other. This means that if two objects that are both positively charged come close to each other, they will repel or push each other away. So vice versa to what we did earlier. So if a positively charged object comes close to a negatively charged object, the two objects will attract each other and try to come together.
Applied force is something with a pull and push action type of motion, and you do it because you want to make something move. You apply force, enough force to actually make it move. Now, to actually draw an FBD for applied force, let's first imagine what would it look like in real life. Let's say, for example, a box, right? Sorry for my setup. A box. Then let's say a person is pushing it. Let's say, not really a good drawer. Sorry for my drawing. Here we go. And let's say the force is being applied right now. So it's being pushed. So we would be imagining it's being applied here. Now we'd put an FA. Now that symbolizes for applied force. It's that simple. This is an FBD for applied force. For frictional force, it is the counterpart actually for applied force because it is the reaction between two objects. Now to draw the FBD for frictional force, let's first draw a box like the other one that we have done, like the applied force. And let's say a person is pushing it again. And let's put here an example for applied force being applied here. Now the frictional force would exist, right? I've said to you earlier, it is a reaction between two objects. So there is a floor here. Let's say, for example, now the frictional force would exist between the floor and the box. So that would be here. That would be a counterpart of F and a small f here. Now that is a symbol for frictional force. And yeah, that's how you draw it.
Normal force. The normal force is an everyday force that is felt when a surface pushes against an object that is placed on the surface. So the example is this picture attached on the other side. And so ayun, hindi naman po siya magsastand sa table kung walang normal force and gravitation. So the next example is the gravitational force. The force of an attraction between all masses in the universe, especially the attraction of the Earth's mass for bodies near its surface. So my example is placed here, and as you can see, ay isa po siyang cellphone. So ang setup po niya is hinagis ko yung phone and of course babagsak po siya kasi merong presence ng gravitational force. Kasi kung wala po yun, magsistay lang po siyang nasa air.
I'm Kobe Dominic D. Cruz and I'm going to discuss two more forces, which is the weight force and the normal force. So I'm going to start with the weight force. So basic introduction to it. So weight is just another word for the force of gravity, which is Fg. Weight is a force that acts at all times on all objects near Earth. So the Earth pulls on all objects with the force of gravity downward toward the center of the Earth. So that is why we're not floating on here on Earth. So simply we're not floating because of the gravity. So to put or to create the FBD and to visualize it, gonna look like this. Imagine that this is a surface, a floor, then a solid object or a box right here. So the gravitational force or the weight force is located and is pointed downward because that is where the gravity is. That is the force of gravity. It is pointed downward for us to stay grounded on our grounds. So Fg. So that's it. Basically, that's the FBD of it. So to create some problem later, I'll give two problems. But first off, I'll just mention that weight is different from mass. So weight is the force of gravity exerted on an object. So mass is a measure of the inertia of the object. So they are related since larger masses will have larger weights due to the formula weight equals mass times gravity. So when we weigh ourselves on a weighing scale, so that is our weight, but that is not our mass. We are here on Earth, so gravity occupies us. So if we are in other planet, our weight will be different. So I'll give two examples to solve for gravitational force. But first of all, we should know that when we solve a problem about forces, creating an FBD first is an essential step to know what we're going to do next and to visualize it. So we already made an FBD, so we're just gonna insert the problem that I'm going to give. So also weight is always measured in newtons. So later I'm gonna show. So let's say, so given number 1, so let's say that we have 50 kg box sitting on the floor. So this is the box. Let's say the mass is 50 kg. So as we mentioned earlier, the formula is W equals mg, mass times gravity. So if we insert the given problem, so which is 50 kilograms of mass, and gravity will always be 9.81 meters per second. That is the value of gravity. That is always the measurement of gravity. So if we calculate it on our calculator, it will give us 490.5 newtons. Don't forget the newtons. So that is the equation for the first problem. That is the solution. So I'm going to give another problem, but it's also the same step because it's always gonna be weight equals mass times gravity. So let's say on given number 2, let's say we have a 97 kilograms of medicine box on hospitals. a box full of medicine and it weighs 97 kilograms. A medicine box is sitting on the floor, resting on the floor, and we're gonna calculate its weight. So it's gonna be 97 kg times 9.81 meters per second squared. So it's going to be, when we calculate on our calculator, it's gonna be 951.57 newtons. Moving on to the normal force. So I'm going to give another basic introduction to it. So normal force is a contact force. If two surfaces are not in contact, they can't exert a normal force on each other. So if a box or a surface is not touching each other, there's no normal force for that. So for example, the surfaces of a table and a box cannot exert normal force on each other if they are not in contact. So if a box and a surface is not in contact, there's no normal force. So however, when two surfaces are in contact, they exert a normal force on each other perpendicular to the contacting surface. This normal force will be as large as necessary to prevent the surfaces from penetrating each other. So the word normal in normal force is not referring to ordinary or commonplace. The normal here refers to perpendicular. This is because the normal force, usually represented with Fn or just n, is a force that is directed perpendicular to the two surfaces in contact. So we'll draw is FBD. Normal force will look like this. If FG is like this, that we mentioned earlier, then normal force is perpendicular, which is upward. It is like Fn. That is the normal force. So should be, normal force should exist, because if there's no normal force, the box will pass right through the surface. So I'm going to give two problems. Oops, I'm not gonna delete the FBD. So it makes sense that the force is perpendicular to the surface, since the normal force is what prevents solid objects from passing through each other. So let's say, given number 1, let's say I put down 45 kilogram of books on my shelf. So what is the normal force now? So in this simple case of an object sitting on a horizontal surface, the normal force will be equal to the force of gravity. It's the same with the gravity, because it is what keeps the solid object placed on this position. So Fn is also mass times gravity. It is equal to it is the same with the gravitational force. So as I said earlier, the given problem is 45 kilograms of books. So what is its normal force? 9.8 times 9.81 meters per second squared. On a calculator, it will solve. It will be 441.45 newtons. So moving on to the second problem. times gravity. It will always be like that. But in some cases, it will be different if acceleration is existing on a given problem, but a given problem is different. So, given number 2, let's say an iPad that has a mass of 8 kilograms is placed on the table and is casually sitting there. So, what is its normal force? So, that is an 8 kilogram iPad. 8 kilogram times 9.81. So we'll do fast solving. So it will be 78.48 newtons.
Good morning, everyone. So for the static and kinetic friction, we are going to answer the question number 1. A 15 kilogram box rests on a horizontal surface A. What is the minimum force required to cause the box to begin to slide if the coefficient of the static friction is 0.20? And letter B, what is the acceleration of the box if the person pushes it with a force of 90 newtons if the coefficient of kinetic friction is 0.20? So the formula in getting the force is F equals US times normal force. Pero since nasa normal force na siya, therefore, ang magiging formula natin ay F equals US times mass and gravity. Yan. So, ayan, kailangan na natin siya i-substitute the values. So, F equals the US, which is 0.20 times the mass, which is 15 kilograms, times the gravity, which is 9.8. Yan. So, ang final na niya is F is greater than 29.4 newtons. Ito na yung final answer natin sa letter A. So, ngayon, ang sasagutan naman natin ay yung letter B. At ang tanong doon ay, what is the acceleration of the box if the person pushes it with a force of 90 Newton if the coefficient of kinetic friction is 0.25? Sa sunod na letra, sa letter B, ay gumawa ulit ako ng FBD, which is nakita nyo naman yan, and kanina. And ito, horizontal force pa rin siya, but then ito, imbis na static force ay naging kinetic force na siya. Imbis na Fs, Fk na siya. Kasi nga, Fk nga yung hinahanap natin sa letter B. So, yun, simulan na natin sa solution. Ayun nga, mga kaibigan. Ito na ang kanyang equation na ating susundan. So, ngayon, kailangan na lang natin gawin ay i-substitute yung mga value nila. So, etong mass ay, kagaya nga kanina, ay 15 AX na siya, equals the force, which is 90 newtons, na nasabi naman kanina, minus the UK, which is 0.25 times 15 times 9.8. And guys, sorry, pangit ako magsulat, pero sana naintindihan. So, ayun nga guys, nung kinompute, ang una nyong makikompute siya dyan, syempre, ito. Ang ginawa ko, edi 15 times 9.8 times 0.25, negative 0.25. Edi yan, nag-isagot ko dyan, negative 36.75. Yun, ito yun. So, ayun, nung pinag-minus natin, 90 minus 36.75, ang nakuha niya ay 53.25. E di, yan na. 15 acceleration equals 53.25. So, ang gagawin na lang natin ay ay i-rewrite natin yun. 15ax equals 53.25. Ang gagawin natin is i-bring down natin yung 15, tapos maka-cancel to, then get the value of this. So ax equals 53.25 over 15. So ang final answer natin dyan ay 3.55. Ayun pala guys, wag nyo kakalimutan lagi yung SI unit na meters per second squared. Yan. Yan ang SI unit ng acceleration. So yan ang final answer natin sa letter B. So ang unang problema ay ito. Sean attached a rope to a 20 kg box. He pulls it with the force of 90 newtons at a 30-degree angle. The coefficient of kinetic friction with box is 0.500. Find the horizontal acceleration. So, yun guys. Sana maging patient kayo kasi medyo mahaba itong prosesong ito. Pero, once naman na naintindihan nyo siya, and maganda to kasi parang may pattern ka na para hindi ka malito sa dapat gawin. So, ayun nga. Ang unang kailangan natin gawin ay gumawa ng FBD tulad nga ng nasabi ko kanina. So, ayun guys. Ayan ang kanyang FBD. And pagpasensyahan nyo na kung pangit ang ating sulat. So, without further ado, sagutan na natin siya. At ang una natin gagawin ay ang letter A. Hanapin ang component method. Gawin to. Component method. Yan guys. So yun guys. So sulat na natin siya. FAX equals 90 Newton cosine 30. Then yung FAY equals 90 Newton sine 30. So, yan guys. Malamang dyan, pag kinalculate nyo, ang sagot na lalabas ay tulad din sa akin. Sure na yan. So, ang sagot dyan dito sa FAX is 77.94 newtons. At sa FAY naman ay 45 newtons. Yan guys. So, yun. Natapos agad natin letter A. Sa step 2, letter B, ang kailangan nating hanapin ay FG equals mg. Mass times gravity. So, ayun guys. Substitute lang natin sa mga given. So, ang mass natin ay 20 kilograms times 9.8 meters per second squared. So, ang lalabas dyan, 196 Newton. Check nyo sa naman guys, ang kailangan nating hanapin ay ang summation of Fy is equals to 0. So, para hindi na kayo mahirapan, ang gawin nyo ay ganito. Fn equals negative Fay plus Fg. Yan guys. So, once na sinubstitute nyo na siya, ang negative Fay, which is yung kaninang sinolve natin, ay negative 45 plus 196. So, ang magiging final answer natin sa letter C ay 151 newtons. Yan guys. Naman natin guys, letter D ay Fk equals UK times Fn. Yan guys. So, pag sinubstitute natin siya, nasa given naman siya, 0.500 times 151. Yan guys. So, ang magiging sagot dapat natin dyan ay Fk equals 75.5 newtons. Yan guys. So, letter E, ang kailangan natin gawin ay kuhain ang summation of Fx. Yan. So, ang mangyayari dyan ay tulad lang din ng kaninang ginawa natin. Mass acceleration over m equals Fax minus Fk over m. So, yan guys. Sulat lang natin siya. I-rewrite na natin with the given. So, Ax equals, so guys ngayon, hahanapin na natin yung acceleration. Ax. So, ang magiging formula natin dyan is Fax minus Fk over m. Di yun, substitute lang natin equals 77.94 minus 75.5 over 20. Ang acceleration natin ay 0.12 meters per second squared. Yun guys. Nagets nyo ba guys? So guys, ano lang, parang intindihin nyo lang din kasi medyo mahaba siya pero gawin nyo nang gawin kasi parang yun lang naman yung technique pagka sa mga number Kasi once na nag-get used ka na sa proseso niya, hindi mo na siya malilimutan. Kaya ayun, maganda na pinapractice natin magsagot ng iba't ibang problems para parang kumbaga nahahasa natin yung mga skills natin para hindi rin natin basta-basta nalilimutan. So yun guys, medyo mahaba lang pero kayang-kaya naman yan and susunod ka lang sa dapat gawin. Walang pasikot-sikot pa. So yun guys.
Now for application of law of motion, I would be teaching you on how to apply the law of inertia, the law of acceleration, and the law of interaction in this following problem. Number 1. A bike travels on the trail with a constant velocity. What is the horizontal net force acting on the bike? What is the acceleration of the bike? If the frictional force acting on the bike is 80 newtons, what is the applied force of the bike by pedaling? Step 1, we'd be applying the law of inertia. It is stated that the bike travels in a constant velocity. So that would mean the speed doesn't change, So we would be using the formula net force equals mass times acceleration. So as I've said, it is stated in the problem that it has a constant velocity, so that would directly equal to 0. For step 2, we would be applying the law of acceleration. Now, what I use personally as the formula for acceleration is A equals Vf minus Vi over time. Now, none of these coefficients exist in the given problem. Now, that would automatically equal to 0 again. Now, for the third and last step is getting, wait, let me read it again. getting the applied force, you know, no, the required force to make the bike move by pedaling. So it is stated that the bike frictional force acting on the bike is 80 newtons. So that would be greater than 80 newtons to make the bike move itself, you know, because slower than it would just make it stationary, because it would not beat the frictional force itself. So let's say the answer here is greater than 80 newtons. Now for problem number 2, a force of 200 newtons is applied on a 20 kilogram shopping cart across a frictionless surface. What is the acceleration of the shopping cart? If the cart accelerates from rest, what will be its final velocity after 10 seconds? How long will it take to the cart to reach a speed of 350 meters per second if it continues to accelerate at this rate? Now, to answer the given problem, let's first answer its questions. First question is to get the acceleration of the cart. So, the general formula for force is force equals ma. Now, in this case, a is missing, so we would be converting it into this formula. A equals over F over m. We'd be dividing force over mass. It is stated that force is given of 200 newtons. Now the mass of the cart is over 20 kilograms. So A would equal to 10 meters per second squared. Now let me adjust the camera. Now for the second question, second step, we would be looking for its final velocity after 10 seconds. Now we would be using this accurate formula of Vf equals Vi plus At. Now Vf is equals to 0 because it is stated in the problem that it accelerates from rest. So it equals to 0 plus acceleration is 10 meters per second squared times time, which is 10 seconds. Now Vf is equals to 100 meters per second squared. Per second, 100 meters per second Vf. Yeah. Now for the third question is how long will it take to reach the speed of 350 meters per second if it stays at that rate. Now for this state, we'd be using the same formula, which is Vf equals Vi plus At. Now the question says that how long will it take the speed of 350 meters per second. Now we would be applying that into the Vf, which is the final velocity, because that is the goal of the speed, the goal of the question, to get the final time for it. Yeah. Now Vi is equals to 0 plus At. A is equal to 10 meters per second squared in time. Now we would be doing this. Let's bring it down. 10 plus 0 is 10 meters per second squared time. Now to get the final answer for it, we'd be dividing both sides by 10 meters per second squared. 10 meters per second squared. Cancel this out and cancel this out. Cancel the squared in the second squared. I'll bring down time. 10 divided by, let me rephrase that, 350 divided by 10 is 35 seconds. Now for the third example, a 6 kilograms speeds up from 10 meters per second to 30 meters per second in 5 seconds. For question A, what is the acceleration? For question B, what is the net horizontal force acting on the object? Now for question C, if the UK equals 0.45, what is the applied force on the object? Now to answer the questions on the problem 3, should be corresponding through them by letter. Now for question A, the question is what is the acceleration? Now the formula that I use here is A equals to velocity final minus initial velocity over time. Now VF is stated to be 30 meters per second. Now initial velocity is equal to 10 meters per second over 5 seconds, as we all know, and that equal to 4 meters per second squared. Now to solve for B, problem B, the question is, what is the net horizontal force acting on the object? Now to get that, we need to use the formula F net equals MA. So that would be F net equals mass times acceleration. Now the mass is stated to be 6 kilograms. Now we have just solved for the acceleration itself, so we just input it there. Now the F net is equals to 24 newtons. Now for the last letter question is what is the total applied force on the object? So first we would be needing to find the Fk. So the formula for Fk is Fk equals to UK times Fn. Fk equals to UK stated to be 0.45. And Fn, we should get that by multiplying gravity times its mass, so that equals to 58.8. 58.8. Now Fk equals to 26.46, if I'm not mistaken. Now we should be getting the applied force through the F net. F net, that should be Fa plus Fk. F net equals, Fa is stated to be unknown, because that's what we're looking for, and we have solved for Fk, 6.46 newtons, and then wait, I have made severe correction. Yes. We have actually solved for the F net, and that would be replaced by 24 newtons. So here, one good thing that my physics teacher taught me is this is always negative, but it depends on the situation. So we're gonna be transposing the 24 here, so that becomes negative, you know. And then FA would be here. FA equals to 50.46 newtons. That is the final answer.